Welcome back to the discussion of spatial networks. In last video, we were looking at physical data model level. This video will continue that discussion and go from data structures to algorithms. Broadly in database term, the query processing. So at the end of this video, we will learn a little bit about query processing mindset for managing graphs. In particular, look for the building blocks. The query processing cannot optimize for everything, but they try to find common building blocks which are frequently used and optimize for that. And then we'll go into further depth for one building block called connectivity query, right, and show you two algorithms. So again, big picture, we are looking at spatial networks. We saw conceptual model, logical model, and now we are into physical model, and in particular, we are looking at algorithms. Okay. So let's first, put the query processing hat and try to see how databases think. So one of the interesting part of databases is that they look at the workload, and then, across many queries, they try to look for commonality. Right? If they can find a common building block, they optimize it very well with multiple algorithms, data structures, and so on. Right? So the same thinking with networks, if we did that, then we'll look for building blocks. For each building block, we'll put some algorithms, sometimes called strategies. And then when a new query comes, we will decompose into building blocks and then rank these algorithms and pick the most suitable one. Okay. This is sort of like, if you drive an automatic transmission car, you just put it in drive, and the car picks whether it's first gear, second gear, or third gear based on the need. And same way, databases are like automatic car, very different from a Java programming where you have to pick algorithm, right? Okay, so if we were to do this with graphs, then people think of at least two common queries. One is connectivity. So essentially, given a roadmap or a trained network, we simply want to know whether we can reach point A from point B. This may look very trivial to you because you might say, well, the network should be designed that way, and many are. But if you are in an island nation, you may have to think about it. But more importantly, there are other spatial networks like electric circuits. So if you think of the power grid and there is an outage after a storm, then this is an important query. The other one you probably expected, shortest path. So shortest path turns out to be a workhorse. Not only it's useful in itself, but it also helps us with many other queries, such as allocating customers to nearest service center and so on. Okay. So many times we think about essentially having multiple algorithms for these building blocks so that, depending on the situation, we can have good performance. Okay. So there are many algorithms, so many of you might have seen main memory algorithms. For example, given that matrix or adjacency list representation, we can use algorithms like depth first search or breadth first search to check the connectivity. And same thing for shortest path. Some of you probably took a data structures and algorithms course, and you may have come across Dijkstra's shortest path algorithm. It's also taught in operations research, geography, and so on. Those of you who might have taken artificial intelligence course might have seen another algorithm called A-star, and we will at least look at these two in our discussion. Okay. Now it turns out that if your data is primarily on disk, some of these algorithms have to be adjusted for the I/O cost. And in addition, there are specialized algorithms like hierarchical routing, which tries to look at only a part of the graph to reduce I/O and still give you optimality. And we'll try to see if we have time to go and visit that. But the main memory one are worth reviewing. Okay. Now also good news is that SQL3 with the recursive statement has been in place, and they have adopted some of these algorithms for use within SQL. So let's look at two algorithms for one building block, that's connectivity query. So in case of connectivity query, given a particular graph and a particular start node, we want to list all the nodes which are reachable from there. And the use cases may be in a smart grid electricity network to see whether power from a particular generating station can reach all the customers. Or in a road map after hurricane or flooding, we might want to see from a, let's say, relief supply distribution center, which particular people needing help can be serviced. Okay. So let's first look at breadth first search, and suppose the starting node is 1. So in case of breadth first search, we visit other nodes level by level. So we first reach the nodes which are directly connected. So from 1, nodes 2 and 4 can be reached first because there is a direct edge, right? Once we have reached nodes 2 and 4, then we try to visit the next set of nodes which are reachable within 2 edges. So from node 2 we can reach node 3, and from 4 we can reach node 5. So essentially your traversals goes by level, starting with 1. We first go to 2, 4 and then 3, 5. Okay. The order within level is not really dictated. You can visit them in any order. The second algorithm is depth first search, and in this case we essentially follow one path till we hit a dead end and then trace back. Something you might have experienced in solving a maze kind of puzzle. Okay. So let's say we start with node 1, and let's suppose we go down node 2, the first edge. Then once we are at node 2, we might visit something reachable by 2, which may be node 3 or node 4. Let's suppose we went down node 3, right? And node 3 is a dead end, we can't go anywhere further. So we go back to node 2 and we say, is there anywhere else we can reach? And we see node 4, right? And then we continue on, and from 4 we can reach 5, and then we backtrack. Okay. So the order is different. So again, give you the visual contrast. Let's compare these two algorithms iteration by iteration, or order of visit. So suppose we started with node 1. In the first iteration, both algorithms may go to a common node, right, which is node 2, because those are reachable by one edge. But in the next iteration, you start to see the difference. The breadth first search goes to node 4, which is one edge away. It prefers that, whereas depth first search is now going to node 3, which may be 2 edges away. And then subsequent iteration, again you will see the behavior change, and you essentially see some differences between the two. So with this, we'll wrap up the discussion of basic introduction to query processing and also algorithms for connectivity query. When we come back in the next video, we will look at 2 algorithms for shortest path query. Thank you. Looking forward to seeing you soon.